Hey guys, just thought to make a quick video on evaporation. Okay, so what's evaporation? Alright, so basically if you have a fish tank of water, hey, if you leave it there long enough, as the time goes by, you'll notice that the water level starts to fall, right? Okay, so that's basically evaporation. Well, in other words, it's just the converting of water from liquid into a gas state. That's it. Okay, so basically, evaporation, you require thermal energy from the surroundings. Okay, in other words, it absorbs heat from surroundings to change the state of substance from liquid to gas. Okay, which is why if you step out of the swimming pool, your body will feel cold, okay, on a dry and sunny day because the water on your body is evaporating. That means immediately after you come out, you see droplets of water, but after a while, those droplets of water, because they evaporate, that's why it gets thermal energy from your skin, so from your body, that's why you feel cold. Okay, so how does evaporation actually occur? Okay, I'll just show you based on a kinetic model. Um, you can see the first rule is that molecules are always in continuous random motion. So you can see all these molecules are basically moving in the liquid, right? So of course, they are not all moving at the same speed, but pretty much the same speed. But there will be some molecules which are actually moving a little faster. So those that are actually moving, these are basically the more energetic ones, that they happen to move a little faster. What will happen? They will be able to overcome the attractive forces, okay, and escape into the air above it, right? Okay, so what does that leave behind? We only leave behind the less energetic molecules, because these less energetic will not be able to overcome, which is why they're staying back, right? So what does it mean? That means the average kinetic energy of the molecules in the beaker actually decreases. So now what is average kinetic energy? We learned from our previous videos that kinetic energy will determine the temperature of the liquid. So over here, since the average Ke decreases, you can also say that the temperature also decreases. So in short, evaporation will always result in cooling. All right. Okay, so some of the effects of evaporation. So which is why, if just now we mentioned about the swimming pool, you come out of it. In this case, will be if you perspire. Okay, when it evaporates, your perspiration actually evaporates from your skin. You actually feel cooler because the perspiration to evaporate, they need to get energy, thermal energy. They need to absorb the thermal energy, and the only way that they can absorb is from your skin. Okay, so next thing, which is why when someone has a high fever, you actually sponge him. Why? Because when you sponge him, um, the water actually, once it evaporates, it actually extract the thermal energy from the body of the person. Okay, a fridge also uses a coolant with a low boiling point so that to remove heat by evaporation and condensation. All right, we know that evaporation has to do with changing liquid from a liquid state to the gaseous state, right? So there's another change that is similar. Okay, and you are right, it's to do with boiling. Over here, you can see I boil water. Okay, you can see it moves. I see the bubbles inside, so it's basically just changing the liquids from the liquid to the gaseous state as well. So both of them are similar, but what are the differences between evaporation and boiling? Okay, many differences are basically six here. Okay, first and foremost, evaporation can occur at any temperature, whether you come out of a pool, depending on whether it's a hot day, it's a cold day, even when it's freezing, even when it's super hot, it doesn't matter. Okay, will occur at any temperature. Whereas boiling for water, it only occurs at one temperature. For any liquid, there will be a fixed temperature at which the liquid boils. Okay, so you can see here boiling also relatively fast, whereas evaporation is pretty slow, hours or even days. And boiling, you can see boiling takes place throughout the liquid. You can see all my bubbles. It's not just on top, it's all the way throughout. Whereas evaporation, just now my previous slide, it shows only those molecules that's able to leave the water surface will be able to evaporate. So that means only takes place at the surface. Whereas over boiling, it takes place throughout. Okay, in boiling also bubbles are formed, whereas evaporation no bubbles. The temperature also remains constant. This one, our previous video we showed you where it changes state. You can see a flat line there. For water, it will remain at 100 degrees. Whereas evaporation, the temperature may actually change because, as we mentioned, once you evaporate, the body actually gets cooler because it needs to extract thermal energy from the body, right? So temperature may actually change. It will not stay constant. And for boiling, you actually need an external thermal energy source. So, for example, here you need either electric heater or direct fire. Whereas for evaporation, there's no external energy source required. Okay. So, the last slide will be just a couple of factors affecting the rate of evaporation. So for humidity, the more humid the air is, the lower the rate of evaporation. It makes sense because it's more difficult to pump in the liquid molecules into the air because the air is really very full of um, 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 gaseous molecules. All right. Okay, surface area also the larger surface area, the higher the rate of evaporation, boiling point of liquid as well. The lower the boiling point, the higher the rate. That means it's easier for the liquid to actually change into a gaseous state. Okay, movement of air. That means if you have wind, a very large wind, for example, you leave your clothes out to dry, the rate of evaporation will also increase. Pressure, reducing pressure increases the rate because you reduce the air pressure, you actually allow the liquid molecules to actually go into the air easier because there's not such a heavy pressure that's pressing against the liquid, right? Okay, and finally, the higher the temperature, the greater the rate of evaporation. It makes sense also because, for example, on a hot day, it's easier to dry your clothes on a hot day compared to a cold day. Right, so basically that's it for this video on evaporation and the differences between evaporation and boiling. Hope you enjoyed this. See you guys in the next.